Hey everybody. So hopefully you watched the quick video about the history of logarithms and where it helps to understand where the laws of logarithms came from. What we're going to do now is, now that we know a bit more about a logarithm and we know a bit more about where the laws come from and how they work, well, now we can go ahead and we can start answering some questions and using these things. So again, the big thing I want you to remember is, despite the whole history lesson, the most important part was the Frenchman and the Swiss guy, Napier, and I can't remember the Swiss guy's name. Their goal was to turn multiplication into addition. Okay, that's the big thing. Now, in the notes, I'm going to go a little bit, I'm going to skip some of the investigation because we talked about it in the other video. Okay, so I'm going to skip down to here. Essentially, looking right here, that I notice that the base of my logs are the same. There's a plus sign in between. So what this tells us is I can multiply what's inside my logarithms together. That's called the argument, what's on the inside. So addition turns into multiplication. So the next one would be 8 times 8, as long as the bases are the same. Okay, the one here, this would be 16 times 4. Right, the next one then would be 2 times 64, which is 128. So again, the goal, or their goal, these two mathematicians, was to turn multiplication into addition. Boom, just like that. Okay, now this is on my formula sheet. I want you to make sure that you're keeping your formula sheet in front of you. Okay, whenever you're doing logarithms, if what you're doing isn't on your formula sheet, guess what? You're making it up, okay? And that's not good to be doing when you're trying to figure out logarithms, okay? So in other words, it says the sum of the logs of two numbers is equal to the log of the product. Product, meaning I'm multiplying the two numbers together, okay? But their goal was to turn multiplication into addition. So I just keep thinking of it that way, okay? Or I could say, conversely, the log of the product of two numbers is equal to the sum of the logs of the two numbers, okay? But again, I think it's easier just to think of it as multiplication turns into addition using a logarithm. Cool. So then we go to part B here, and it says the differences of logs. Well, like in the video I said, if multiplication turned into addition, right here, division is going to turn into subtraction. Boom. Or if I'm subtracting, I can combine it into 1. So what you're going to be asked to do when you're doing these questions is to go between both forms. So going from more than one log into a single log, that's called simplifying. Going the other way, going from one log into more than one log, is going to be called expanding. There we go. My pen quit working there. Expanding. Okay. Simplifying is way more important. If we think just of like whatever polynomials or radicals, whenever we've done those questions, simplifying is always more important. Okay. Now, the one thing I do need you to notice here is when we're doing these things, notice that the coefficient when we're combining is 1. And the coefficient right here on these guys is also 1. Okay, so the question is going to be, what do we do when the coefficient's not 1? Well, that's coming up right now. Okay. Now I'm going to again skip over here to part C, because in the other video I explained to you, and that's why it's important you've watched that quick video, this law. What can we do with that exponent? that exponent can become a coefficient. Okay, so that's called the power law of logarithms. But again, what I need you to know is really that the exponent can be moved to become the coefficient. Okay, and again, I explained why that works the way it does in the other video. It's because logs are cool. That's the answer you're looking for. Okay, let's play around with these three laws. So you got your formula sheet in front of you. You're looking at everything. You're always looking at your formula sheet, okay? I still do, never hurts, right? Okay, so this first question here says, we're going to expand. Means I'm going to make it larger. I see there's a multiply sign there. And I see my multiply sign right there. So that means I'm going to, their goal was to turn multiplication into addition. There it is. Those two things are equal to each other. They look different, but they're equal to each other. Next one, there's no numbers. Doesn't matter. The rules are still the same. Their goal was to turn multiplication into addition. Done. Okay? Now, expanding, not as important, right? Usually we want to simplify. So simplify means we're going to write it as one log. So here we go. Number 5. I see a plus sign right there. Right there's my plus sign. So that means I'm going to multiply these things together. I'm going to multiply the arguments, what's inside my logarithm, together. And then I'm just going to simplify that. Now make sure when you're first writing logarithms, it's a common mistake to write them a little funny. Make sure you're writing that base 3. It's kind of a subscript. So log base 3 of 35. Okay, looking at B here, let's go pretty pink. I notice the bases are the same. I'm never going to mess with you. In 30-2, the bases will always be the same. And I'm going to multiply the arguments together. B times C. Done. C. Well, C, I notice there's a subtraction in between. Right there. There's a subtraction. So when there's a subtraction, that means I'm going to turn this into division. Log base 2 of 5 divided by 3. Booyah. Done. Okay, the next one, again, no numbers, don't care. Bases are the same. There's a minus in between. I subtract. Look at that. Okay, so simplify again. The word simplify means I'm going to combine all my log terms into one. Now, this question here, number 5, only had 2 logs. Really, I could give you as many logs as I want and say, let's combine them all together. But for us in 30-2, it's usually 3 logs max. I'm not going to make a rule and say it's going to be that, but usually that's where we stop. Okay, I can tell if you know what you're doing after about 3 logs. Okay, anything more than that, it's just being cruel and unusual. So 6, simplify into a single term. Okay, well, I'm just going to look at this as 2 parts. The first little while I'm doing this, I'm just going to do it real slowly. There's a plus sign in between, so I'm going to multiply those. Boom. Now I'm going to simplify it all together. Well, when there's a minus sign, that really means division. So, just like that. Okay, so you can see what I mean. When there's more than 1 log, it doesn't really change what you're doing. Okay, starts as you get good at this, skip steps. Don't show me the first step. Now B, you're going to put a huge star beside B, because this is where there's a little rule that I need you to know. Really important. I talked about it a little bit earlier. If you look at your formula sheet never shows there being a coefficient. So if there's a coefficient, here's the first thing I'm going to do. I'm going to use my power law of logs. And what my power law of logs says is I can bring that coefficient up and make it my exponent. Now I can use my law of logs. So I'm going to do this all in one step. Anything that's adding means I'm multiplying, means I'm going to end up in the numerator. Anything that's subtracting, I'm going to end up in the denominator. So let's write that big rule down there. Let's go for, what color do we want? Pretty red for a big rule. When I'm simplifying, must turn coefficients into exponents first. Okay, I can't stress that enough. Okay, so if I go on ahead and I look at C, the first thing I notice is I start seeing this coefficient of a half flying around. So I'm going to rewrite this right off the bat as that. Okay, so coefficient to exponent first, and now I'm free to use my laws of logarithms to simplify. Okay, so really if I'm looking at this, the biggest thing I need you to be noticing here is this rule. Not really a rule, but it's in the laws of logarithms that shows that there's no coefficient flying around. So if there's no coefficient in my laws, I got to get rid of it in my work. Okay, D is probably the trickiest one. So first thing again, coefficient to exponent, right? So a squared. Now, why I'm saying this one's going to be the trickiest, because some of you are like, well, it looks exactly like the last one did. It does, but notice how this one, there's two subtractions. Well, anything that's positive means I'm multiplying. Anything that's got a minus, I'm subtracting, I'm dividing. So really what I want you to think about, if I'm dividing, I'm going to end up in the denominator in the bottom. And if I'm multiplying, I'm going to end up in the top. So when I'm dividing, the b, I'm going to go a squared divided by b, and then I divide by the c cubed, and look at that. Everything ends up, the b and the c in the denominator. Okay? If you've got d, you're like, yep, I got this, and you're good to go. You're totally following along nicely. Okay, there's how the laws of logarithms work. Okay, we get a lot of questions about simplifying these things. Now, let's continue on here. Almost done. Number 7 says, simplify the following without using your calculator. Well, one, you got a calculator, but this is going to be really important for what we're going to do in the next couple lessons. Okay, so even though you have a calculator, you got to pay attention to this. Okay, watch what I'm going to do here. This goes back to something we did in the last lesson. So what I'm going to notice here is that I've got a base of 2 and I've got this 8. So I'm going to change that 8 into 2 cubed, just like that. And what can we do with that exponent? We can use the power law. That 3 becomes a coefficient. And I didn't leave you much room here, but do you remember what happened with this piece right here? Remember from the last lesson? When the base and the argument are the same, that's really just log 2 divided by log 2. That's just 1. So guess what? This is really 3 times 1, which the kids tell me is just 3. Okay? So this is a little tricky. This is where I'm going to look at the next one. I'm going to change the base and the argument to be the same thing. This is where logs start to turn into puzzles, okay, where I'm really testing if you understand the laws of logarithms. Now, that 2, the exponent, comes out, becomes my coefficient. Well, I've already got a coefficient, so I'm going to multiply those. So that'll be 6 log base 4 of 4. And guess what? Base 4 of 4 again is 6. Okay, we'll do one more. We'll do C. Well, C says there's no numbers. So this is what we're going to start moving towards in our next lesson. Okay? I can't stick that in my calculator. You have to know the laws of logs. No big deal. The exponent becomes the coefficient. Log base x of x is 1. So guess what? This bad boy is just equal to 5. Okay? I mean, really, that's it right there. That's the important part. Well, let's look at D. (32) is really 2 to the exponent 5. So if you're following along, you're probably already figuring out that's just 5. And log base 3 of 3 is 1. So this is really just 5 minus 1, which is 4. Done. Okay. Again, this is all about, can I use the laws of logs, right? So this is where you get these puzzle questions to see, helps me understand if you understand how the laws of logs work. Okay, let's wrap this up with our summary. And we are good to go for yet another lesson. Okay, here we go. Let's go, what pretty color? Pink. Okay, there's 3 laws of logs that we must know. Or, I look at my formula sheet, right? For any of these laws to work, the bases must be the same. Okay, I will never mess with you and not make the bases the same. Okay, I think the biggest thing that's going to come up when you're trying your practice here, when simplifying several terms into one, always make the coefficients into exponents first. Okay, that is an absolute must know. Okay, and then this last one here, again, it's not on my formula sheet, but log base a of a is 1 because it's really log a over log a, and we know anything divided by itself is 1, right? That's your change of base formula. Okay, I hope that helped with the laws of logs. Okay, again, the history lesson, you don't really need to know all of it, but you need to know that those 2 scientists, mathematicians, their goal was to turn multiplication into addition. They did that using a logarithm. Everything comes from there. Okay, guys, I will see you for the next one shortly. Hope you're all doing well.